All right, so let's see. If we have a bullet now, I'm going to look at this for our work example. We're going to have a bullet. All right, it's going to be 10 grams. It'll be moving at a speed of 400 meters per second. It's going to hit a tree. And it's going to lodge in, let's say, 2 centimeters. All right. Probably should use a different color. Oops. Let me go backwards. So it's going to go in 2 centimeters. Let's just do this. And so we're going to want to use that to figure out how much force is on the bullet. And we're going to do this indirectly. We're going to do it indirectly with the work. So remember, the work was basically, or the energy, kinetic energy was basically how much energy it took to stop the bullet, right? And the work was the force times the distance. So, just put force distance here. Kinetic energy is 1/2 mv squared. So we want that force. Okay, we know the distance, it's 2 centimeters. So let's just come down here, the force times 2 centimeters, which is 0.02 meters, is equal to 1/2 times the mass. So that's 10 grams, so we want to put that in kilograms. So that's 10 grams over 1,000 grams per kilogram. Times the square of the velocity, which is 400 meters per second squared. Okay, so we want to square that part. Then we have our force here. Let's just leave that as 0.02 meters here first. Let's see what happens here. So 400 is 16, 1, 2, 3, 4 of these guys, meters per second squared. So I cancel 2 of those. This is 10 grams, so I'll cancel 1 of those. So I have 1600 divided by 2, which is 400. Kilograms, meters per second squared. Is that right? That's 800, excuse me. 16 divided by 2 is 800. Okay, keep making mistakes. All right, so we'll divide by 0.02 meters. 0.02 meters. And so cancel that out. This does another half, so that's 4. Then we add 2 more zeros. So 4, kilograms, meters per second squared. So I'm canceling out one of those meters. Okay, and this thing here is called a Newton. So we have 40 kilonewtons. Okay, so 40 kilonewtons. All right, and when I came over here, I was seeing there was a problem, and here was the problem, is that I'd already done the conversion in my head and didn't notice, so we left those out. But basically, we looked at the 2 definitions of work, 1/2 mv squared, and or the kinetic energy is 1/2 mv squared, the change in the kinetic energy, and FD is the force times the distance, right, which is the definition of the work. So one is actually the work energy theorem. So the work is the change in that kinetic energy. The force times the distance is our other definition. made our substitutions. If I'd done the substitutions right, we'd have 80 here, and then we'd have 400 over here. No, 800 here, 40,000 newtons. Okay, so we're just making our substitutions and getting it over with. This is conversion, right? So that's enough for this one. We'll go on to the next one, or the next part, where we're going to talk about temperature.